The second implication of ROHS is that prompt engineering will go away eventually. Like it is something fleeting. And the prompt engineers is just not a real job. Let's face it. The reason prompt engineering will not be relevant forever is because of ROHS. Why prompt engineering even exists in the first place is because these systems are misaligned with what humans want. So we have to kind of coerce the model to give us what we want by typing out very unnatural sentences and to essentially trick the model into solving the task.
Hey there, I'm your host, Kan Jun, and we are Generally Intelligent, an independent research lab developing AI agents that mirror the fundamentals of human-like intelligence and that can learn to safely solve problems in the real world. On our podcast, we interview researchers about their behind-the-scenes ideas, opinions, and intuitions that are hard to share in papers and talks. We hope you learn as much as we have in our quest to understand and build the mind.
Jin Fan is a research scientist at NVIDIA, and he got his PhD at Stanford under Fei-Fei Li. Jim is interested in building generally capable autonomous agents, and he recently published MineDojo, a massively multiscale benchmarking suite built on Minecraft, which was an outstanding paper at NeurIPS. We're really excited to talk to you about MineDojo and also a lot of the other work that you've been doing. Tell us a little bit about how you got started. How did you develop your initial research interests? Where did you start out? And then how have those interests evolved over time? So let's start from the beginning.
Yeah, I really love telling the story about my journey in AI. So, started from sci-fi, right? Like I watched Iron Man for the first time in 2011. And then I think the Iron Man suit is really cool. But honestly, I'm not as interested in the armor itself, but as the AI operating system that runs Iron Man and also like his house and everything on the defense system. And that system is called Jarvis. And I feel that like after 10 years, ChatGPT is similar to a prototype of Jarvis, but that's another story. So that movie really inspired me in 2011. And then I became a student in AI and machine learning in 2012. And that coincides, it's pure coincidence, didn't apply for it, but that coincides with the first year of AlexNet, which started the whole deep learning revolution. So I still remember that year, like kind of the thrill when I read like a freshly baked AlexNet paper, just like out of NeurIPS, right? And I really appreciated its simplicity and minimalism. So, many of the new students might not remember, but there was a time in computer vision that you need to use like 7 or 8 complex hand-engineered featureizers and all sorts of different objectives to optimize for. And then there's a cascade of unwieldy pipelines. So that was before AlexNet. But then AlexNet hit, and this minimal, simple, and really elegant system gave me like another stroke of inspiration. So that kind of started my journey doing more serious studying and also researching AI. And after that, I started my undergrad in 2012. Back then, I was still a freshman at Columbia University. I started to kind of collaborate with different research labs and jump around quite a lot in terms of topics. But all of them are in deep learning and neural network. So just to give some examples of the jumping around I mentioned. So I worked on NLP at a chemical engineering lab. So we used NLP to parse papers in the chemical engineering literature and kind of to harvest knowledge from it. Admittedly, it's way ahead of its time, but it looks very much like the Galactica model that's trained on like science literature. But of course, back then we didn't have neural networks. We didn't use neural networks for that particular project. And then I also work on speech recognition. It's called the deep speech system, like one of the first large-scale end-to-end speech recognition for English and Chinese. And for that project, during my internship at Baidu, led by Professor Andrew Yin, I also work in semi-supervised learning at Mila with Professor Joshua Benjo, and also video action recognition later during my PhD time, and large-scale distributed systems. So kind of like all over the place a little bit. So in terms of like RL terminology, it's like exploration versus exploitation. I think my exploration time is pretty long, probably longer than many other students. And finally, maybe in like the kind of the last couple of years of my PhD, I converged on reinforcement learning, or more generally, like policy learning and embodied agents. So that's kind of the quick summary of my 10 years in AI.
You were at Baidu working on deep speech, and then you were working with, at Mila and also at Stanford. Like, what were some of your early questions that you were interested in, and what was the sense you were getting from seeing the progress in all of these places? And then how did you eventually converge on RL?
I think that's a great question. So the fact that I jumped around a lot means I kind of get into like different fields at different points in time. And I observed that all of these fields, like including speech, video, semi-supervised learning, distributed systems, all of that start to use like neural networks instead of hand engineered pipelines. So like all of these fields are converging towards that. But the other thing that I didn't like when I was jumping around is that you need to have still a lot of domain specific biases in each of these little subfields. Like in speech recognition, you need to learn a lot about like Milgram and all of those speech features. I mean, even though like the rest of it is like RNNs, but still like this input and output pipeline and the architecture is very much overfitted to speech recognition. And then also the same thing with videos, right? We use like 3D, like variants of 3D convolution networks. And in my particular work, we developed like a new kind of 3D neural network based on the shift operator, another very, very specific thing that only makes sense in video and doesn't work on speech. It doesn't work on NLP, right? And just by kind of traveling across all of these fields, I feel a bit exhausted. Every time I get into a new one, I want to do some exploration. I have to learn their domain knowledge and their jargons. And then what really strikes me, I think starting like 2018/2019, was this big convergence across all of the AI fields on like transformers and large foundation models. And I think like that is the moment I feel AI is starting to work. Like before that, you can use AI. It's more kind of like domain specific automation tools. It's not really general intelligence in any sense of the word. But after that point, I feel, okay, now AI is really working. Now we can have maybe one model that can learn them all. So that is like one very general paradigm that I'm converging towards. And the second general paradigm is like reinforcement learning and embodied agents. And I think the capability of policy learning also grows with like these advances in unification across modalities and in this kind of general purpose architectures. Like we see things like decision transformer making their way into RL and policy learning, and also the whole idea of scaling up models on policy learning. And these things also make RL and embodied agents starting to work, probably for the first time. So that's what inspired me. Yeah.
And when you were thinking about, you kind of saw the big convergence on transformers, and then you started thinking about RL and embodied agents. Why RL and embodied agents at all? There are people who are maybe not that interested in embodiment. What is it that made you feel like it was interesting?
I think the other inspiration comes from just observing how humans learn, right? And one of my favorite analogies is look at human babies. As Alan Turing said, don't build an adult using AI. You build a baby and then have that baby kind of grow and explore and then augment its own intelligence. So for human babies, let's say a 3-year-old, they know much less pieces of knowledge than GPT-3 or even just a modest-sized bird. But they're already like little scientists in their own right. So they use all their senses and motor skills to kind of conduct experiments, enact changes in the environment, sometimes messy, but those are the changes they make. And they observe the consequences of their own actions. And then in this process, they become better and better at exploration and also faster and faster at acquiring new concepts. So I think to human babies, like just for example, right, the word apple is not just a single token or a group of pixels. I think it's a deeply immersive experience, like the texture of an apple, the weight of it on your palm, the smell, the taste, or even like its appearance in a bedtime story, like apple hitting Newton, or your mom's apple pie filled with love and joy and this kind of whole memory associated with it. So the word apple is a deeply immersive whole packet of it inside this single concept. And I don't think GPT-3 or any of the recent large-scale foundation models are able to have this holistic experience. And this thing only comes from embodiment through this kind of interaction with a very, very rich world, an infinitely rich world, and then internalize all these experiences. And that's why I'm very excited about policy learning and embodied agents. I think that is kind of the next front of revolution. So don't get me wrong, like GPT-3, ChatGPT, they are great, right? Like they solve many of the problems in the text domain, but they don't have arms and legs. They cannot actively explore visual world, and their knowledge is ungrounded, right? Like they can tell you all about Apple, but not kind of the whole immersive experience.
Well, some language modeling maximalists might push back on that and say, well, but what about, all the does learn about like apple pie from internet, because people do write about like their memories of apple pie, and like, oh, how their mom made an apple pie. Well, it is getting all these other concepts from language. Like, do we really need to have embodied cognition, or can we just get away with internet language? How would you respond to that sort of position?
I think multimodality is very important. For human brains, like 70% or something, I don't know the exact number, but definitely more than 50% of your cortex is dedicated to visual processing. And why is that? Right? Like the visual world is so rich, and also like all the senses, all the taste, all the smell, like why do we need all of these? And I think like this kind of whole package of sensory motor functionalities, and they really help ground our knowledge. I think the grounding here is one of the most important keywords. Like, yes, GPT-3 can parrot back about, apple pie and maybe like fake some of those emotions, but is it grounded? Is it grounded in the pixels, in the taste, in the smell, and this very deeply immersive experience? And I feel it isn't. So I'm pretty sure many people will still disagree, but I guess time will tell. Like, are we stretching the limit? Maybe we'll see GPT-4 very soon, but is GPT-4 going to be kind of the limit of what you can do in a single modality? I feel it's going to stretch the limit. I mean, you can 10x the data. You can 10x the parameters, but it's not going to give you emergent new capabilities. Mm-hmm. And that's where like the kind of the last, or, the post GPT-4 era will be about adding all of these multimodal senses back, adding decision-making back, so we can have this holistic experience for the AI.
It seems like as some of your prior works, you kind of had a bunch of different like simulators and ways of poking at like, how do we actually instantiate? So you want to walk through sort of how that started and how they've evolved. Maybe the first one looks like Surreal. Maybe is the first one.
I think World of
the World of Bits is even before that. Although that one's not as embodied, but that does seem like kind of the first one.
I mean, it is kind of embodied on the web.
Yeah,
yeah.
So I guess we can start with the World. Starting with World of Bits, how did you get involved with that? What was your sort of experience with that?
Yeah, I think like the lens through which I view these prior works of myself would be by the scale of universality, right? The generality of the environment. The first work was kind of the least universal one, was like Surreal, the environments investigated in Surreal. And for those of the audience who are not familiar with the work, it is like an open source kind of large scale distributed RO system that can solve robotics tasks in a simulator. So we use like physics simulator to simulate some robotic manipulation tasks, like having two robot hands lifting up a heavy pot, things like that, or stacking some blocks on top of each other. And then we use just reinforcement learning, but massively scaled up. And also like the whole framework was open source. And we applied that to these robot tasks that people thought were very hard and required maybe new like innovative algorithms. But we showed them you don't need any of that. Just scale a PPO, make it efficient, make it parallel, and then you can do a pretty good job at it. Right. So I think for that paper, the main point is to prove that PPO with scaling up can do really well, but not necessarily in terms of whether that environment wasn't general. And we don't think like Surreal was able to kind of have any form of general intelligence emerge. So that wasn't the point of the paper. But then like two of my later works, I feel really touched on this theme of kind of universal intelligence in terms of like decision making and feedback loop. So one of the earlier work was World of Bits. So that work used internet and like web browser as a policy learning environment. And here, if we break down policy learning, typically people talk about three concepts like observation space, action space, and the reward function. And for that particular work, our observation space is the web page. So how can a web page be represented? The most universal way is to represent it by pixels. Just take a screenshot of the browser, right? That's super universal. Works on any of the websites. But you can also add structured information to it, because for many of the web pages that have a lot of text, you can extract the DOM tree, the document object model tree from it, and you can get some text out of it. So that's like another way to extract more information than just pixels. Otherwise, you're implicitly doing OCR, which is also fine, but it's a little bit dumb. So that's the observation space. And then the action space, also pretty straightforward. Keyboard and mouse. That is kind of the most universal control that you can have inside a browser. And then the third thing is the reward function, but that one is task specific. And in the World of Bits paper, we defined a new benchmark with like thousands of tasks. Some of them are like question answering. I ask you, what is kind of the best recommended Mexican restaurant in Miami? And then given this question, you go to Yelp, you type by controlling the keyboard, and you maybe scroll using the mouse. And then you find kind of the top rated restaurant on Yelp, and then you return the answer. And we do have like a benchmark with ground truth answers. So we know your accuracy. So that is kind of the reward function. And for some other tasks, it's like, completing certain operations. And for those, it's more like training the motor skills of using keyboard and mouse. So one example is what we call the mini worker bits, which are like little, JavaScript puzzles. Like you need to drag this yellow ball into this green box, for example. So you need to kind of have some control mouse with a little bit of finesse, right? You need to point and then drag and then drop at the right place. And we can measure your reward by the progress towards solving the task. But again, that is super task specific. Let's say in that particular example, it's like the distance between the current ball and the box and the destination box, and you can shake the reward. Yeah. So I would say like for world of bits, kind of the observation action spaces, they're universal, but the reward functions are more like task specific and kind of also like handcrafted. And by hand, I mean hands of our co-authors with a lot of pain and sweat. We just curate this whole thing, right? Like just did everything in house mostly. So there was that work.
World of Bits, I'm curious, how did you decide the types of tasks in that work? Like was it brainstorm or what was the framework for thinking about it?
It was mostly like brainstorm, like we just discuss among ourselves the tasks that are interesting and not too difficult, also not too easy. And it's very easy to think about difficult tasks, right? Like there are so many things online that even for humans, it's going to take you a while to do. And also there are like many online games. Technically, they're also browser tasks, but they're not really. So we kind of exclude those. It's more like we're focusing on web pages that have like information and like regular kind of keyboard and mouse controls. So indeed, like we exclude a lot of universality from this otherwise super universal observation action space.
Of course, like an agent that can browse the web and do any task you want, like a kind of holy grail generalist agent. I'm curious, when you think about that work today, are you interested in this browser environment at all? Or were there things you learned from World of Bits that made you feel like the web browser maybe is not a good learning environment?
In full honesty, like I am very conflicted on it even till today. Generality in this kind of keyboard and mouse comes at a very high cost. And that is kind of the computational complexity of it. And the more important question is whether it's even necessary. Is this complexity even justified? So I've been observing applications built upon ChatGPT, like there are like thousands almost every week. And there was like a bunch of applications using ChatGPT to navigate the web, to like search for information. And very much keyboard and mouse are not needed. You can kind of just give us a list of links to ChatGPT and it can navigate through the links by directly just reading the text. Do you really need to learn how to point your mouse to that specific location of that link and then execute a click? It's unclear to me. But on the other hand, if you want generality on anything on the browser, that's not just text, but you can also manipulate images or other things in a Chrome browser, then maybe this kind of generality is justified. But again, I'm not clear on it. I think it's application or like downstream task dependent. If all you need is like synthesize information, I don't think it's necessary. But if you need something fancier, I think maybe it is required. And also that points a little bit to the Minecraft series of work as well. Not just MineDojo, but the other work is called VPT that explores this. I have more to say about it later.
Cool.
On World of Bits, how do you feel about what sort of happened with it afterwards? Like, do you feel like it accomplished the goal that it was setting out to accomplish, or it sort of, I don't know, let's see, how many people have used World of Bits? I feel like it's not as popular as I would expect.
Yeah, it's
It
such
seems
an
like
interesting,
yeah.
such an interesting task space.
Yeah,
Like, why
what,
is
what
it?
happened?
Why? Yeah.
Yeah, great question. I think it was an interesting idea that's way ahead of its time. Because back then, yes, we can solve many world of bits, but is that task useful? It's not useful in an application point of view. While things like ChatGPT, they become very useful in real applications. It's like more like grounded usage. So I think world of bits ask more questions than it answered. So it's asking these questions, are these action spaces justified? And if you want generality, you need to pay this price, but how do we play this trade-off? How can we decide what is the right trade-off to make in a particular application? Like world of bits sparked many questions like this, but I don't think it answered many of them. And still many of these are unanswered even till today. I was actually super excited last year when I saw a startup called Adept that is essentially a modern incarnation of world of bits. It's same idea. And they literally have almost the same task, like asking what is kind of the best like house in a particular region to purchase given this budget. And they go to some housing sales website and then do that. It's very, very similar to all of it. And they, of course, use like transformers to do it. It's called ACT1. And they did not release any details about the algorithm, like what is the observation action space. It's a bit unclear. But from the demo, I don't think it's like fully just keyboard and mouse. I think they're doing something like on a higher abstraction level. And that points back to the questions I asked, like, is that really necessary, right? To go down to the super low level motor skills. And for startups like Adapt, depending on different applications, you really don't need that. And if you're like super opinionated on going always to the lowest level, then from a business point of view, you will incur a huge computation cost that's unjustified, right? Like every iteration of transformer costs you like real hard cash. So is that a good idea? I'm very interested to see where Adapt will go. And I hope they can release a bit more about their research, just sending this message to them.
I really,
Yeah.
I'm curious, what
Yeah.
questions from WorldBits do you feel like have been answered the last few years?
I think one thing is kind of how to, I would say, like synthesize information by browsing the web. So that is definitely a big question WorldBits asks, in addition to defining the observation action space. And I think that's pretty well solved by many of the works in like NLP, be it like ChatGPT, or there's another work called WebGPT that kind of goes on the web, search for information and then synthesize, and also like countless other works from other labs doing this. So like in short, I think the Google search part of WorldBits is well addressed by the community. And maybe like very soon we'll see like some upgrades to search in general. So Google search hasn't changed for like a decade, but now they may be pressured to finally change. Instead of humans clicking through the link, we should have an AI that navigates through those links and grab the most relevant information for us. So I think that part is a really valuable conversation WorldBits started. I think it's going very strong.
What are the most important open questions from WorldBits? So do you feel like today, like, yeah, this is still like a really, like the most important thing. It's sort of unsolved or we're not really sure about. Is it the like how to do the representation, or is it something else?
I think I'm still really amazed by how humans do this task, because we are doing the lowest level of control, right? Like we do the keyboard and mouse controls. And if we want to be like stricter about the concepts, we're sending neural signals to our fingers and then controlling the finger torques, the torque in each joint to operate a keyboard and also like using a mouse. It's incredible how low level we're going as humans to do WorldBits. And we seem to have very little problem with our computational efficiency. But I guess procrastination is our problem that AI doesn't have. So that is our unique problem. But otherwise, we're computationally efficient. We're very efficient. So I'm just wondering, like, maybe there's a way to actually make the lowest level, the most general action space, computationally tractable and even like more efficient than we thought it would be. I think that is a big open question. And if we can solve that, then we don't have that trade-off anymore. If it's as economical to run the keyboard and mouse action than, doing some fancier, more abstract action space, then we should always go for the lower level because they are more general, right? If we don't have any extra cost of that. I'm very excited by that prospect. I don't have a good answer to it, but I think, we may have some cool answers there.
Yeah. We have WorldBits, and that's great. We have Surreal. So what were kind of the things that you felt like were missing, and what kind of prompted MineDojo and some of the other later work?
The weaknesses in WorldBits directly inspire many of my later works. And in particular, I would like to talk about AI for Minecraft or the MineDojo work. So as I mentioned, there are three parts: observation, action space, and reward function. I think the observation action spaces of WorldBits were very clean and elegant. The reward was a complete mess. Like, it's like task dependent, it's like hand curated and not scalable in any way. So like, how can we kind of address these problems? And also in addition to that, WorldBits would still, it's not really embodied in terms, if we're going strict, right? Like it still doesn't have arms and legs. Yes, it has an action space, but it's not like being surrounded inside a 3D world and having some like really sophisticated visual system to help navigate this world. Like it's not the immersive experience that we discussed at the beginning. So the two things, right? The rewards, the messy reward functions, and the lack of this immersive, like true embodiment. So in MineDojo, we kind of addressed both of these. Let me give a quick introduction to MineDojo. So I think the kind of a big goal is to build something like an embodied GPT-3, where we just give the agent like a natural language prompt. let's say, build a castle by the sea. And then this agent can take this prompt, understand it, and collect all the resources, do all the necessary exploration, and craft the tools, and then build this castle for us. And we don't have any algorithms that even get close to this ideal of embodied GPT-3. And that is kind of the grand vision for MineDojo. So MineDojo is a large-scale framework for training this kind of open-ended generalist agent. And we have a recipe of 3 essential ingredients in this work. So the first thing is an extremely rich environment that can support not just 1 or 10, but an infinite number of tasks. And that's why we choose Minecraft. It is not a hard choice because it's one of the only games that is truly open-ended. Minecraft doesn't have a single score to maximize, and that's unlike Atari games. And there's also no fixed storyline, and that's unlike most other games. You beat a final boss and you're done with this game. You don't go back ever. But Minecraft people come back to it over and over again because every time they discover and build something new, right? It's an infinite number of tasks and you can do whatever as your imagination permits. So that is kind of the first part. This environment itself needs to be open-ended and extremely rich. And the second part is an internet scale database that teaches an agent not only how to do things, but also what are the useful things worth doing. So here, Minecraft has a very appealing property. It's got a mind-boggling 140 million active players. And just let me put this number in perspective. So 140 million is more than twice the population of the UK and almost like 10,000 times the size of the NeurIPS conference we just attended, one of the largest AI conference out there. It's incredible. The number of humans actively playing this game is mind-boggling. So the good thing is they produce a huge trove of online knowledge every day, right? Because people are so excited about this game. And then the question is, can we tap into this very rich, unstructured data? So in MineDojo, we provided 3 open databases. And the first one is we collected 700,000 YouTube videos with 2 billion words in transcript because gamers actually love to narrate what they're doing when they're streaming. Second, we scraped all 7,000 Minecraft wiki pages that essentially explain every entity and mechanism in the game. People are like so enthusiastic about this game that they documented everything. It's like an encyclopedia of all that you need to know about this game to play well in it. It's pretty incredible. And the third, we collected more than 300,000 Reddit posts where players showcase their creations or sometimes ask questions as if it's a Stack Overflow for Minecraft. For many of the tough questions, we can actually get really good answers that human players provide on how to solve particular tasks. And that is all on Reddit. So MineDojo's internet database is one of the largest kind of open database out there for agent learning. And that is the second part of MineDojo. And now that we have this simulator and data set, it's time to train a foundation model for the agent. So our idea is called MineClub, and it's actually pretty simple. Because our YouTube data has time-aligned video and transcript, then we can use contrastive learning to learn an association score between the video and the text. And this model essentially becomes an open vocabulary reward function for the agent. So here we have a much more elegant way to do this reward function. We no longer write down a reward function for every task we care about and then kind of painstakingly like test it in an algorithm. But now the reward is learned from all the human play data that we collected. So like no more kind of sweat and tears from the Colossus writing down those functions. And now we can just like leverage whatever is already out there on the web. And also it's growing every day. Like there are thousands, tens of thousands of videos uploaded every day about Minecraft. So this reward function can scale with more data, with more time. So that is something fundamentally different from WorldBits that we're very excited about. Mm-hmm. And now you have this reward function. We can just plug in any RL algorithm. And now you have a Minecraft agent conditioned on natural language to do many tasks. This is all like really cool, but I do want to say what we can do is very far from the crazy ingenuity that human players have demonstrated. In MineDojo, we can only solve dozens of tasks that are pretty short horizon, which means the task doesn't last like an hour. It's more like getting wool from sheep or doing some harvesting resources. For that, MineDojo can solve. But online, on YouTube, I've seen videos of people building the entire Hogwarts castle, block by block. Yeah, and even simulating a functional CPU circuit using redstones within Minecraft. And these things, like they can take maybe a few months to build. The horizon of this task and the complexity of it is just staggering. I'm speechless. I can't even do this as a human. It's like superhuman creativity.
Yeah.
Right? I can't even do that.
I saw the most mind-blowing video of people building Minecraft in Minecraft. And then now they could play Minecraft in Minecraft, running the CPU.
running the Minecraft. Exactly. I've also seen that. You can go like, full Inception mode.
Yeah, exactly. And
it's crazy. Yeah.
It's interesting. How did you come to Minecraft as an environment? Were you playing it yourself? Did you look at MineRL and feel like, okay, maybe there's more here that can be done? Kind of how did it happen?
I'm very glad you asked. It's just a story I've told very few people. I am actually more excited about watching others play Minecraft than playing it myself. That's a very weird thing to say, but I'm a terrible gamer. I'm a terrible gamer. I have like very bad kind of motor coordination skills using keyboard and mouse. This is not my action space. No, not good at this. And actually even worse, I have pretty bad motion sickness. So I actually get motion sick after maybe playing like 2 or 3 hours of Minecraft. It's very sad. So like at one point, I really need to play it to understand all the nuances and things, right? So at one point I had to take like seasick pills to play this. So that is my dedication for science, right? Putting out.
Take nausea pills.
That's right. Yeah, take nausea pills to play Minecraft at work, right? Dedication to science. Yeah. And I think like my experience with Minecraft really also helped shape this project because I watched like so many videos from online and I was thinking, why can't our AI agent also learn from all of these great tutorials that people put out? Because frankly, Minecraft is not an easy game, even for humans. If you have never played Minecraft before and have never kind of studied the wiki for Minecraft or watch others play, it's hard to figure out what to do in your first day. Minecraft gets scary really fast because after a while, the night comes. So they have day-night cycles. After a while, the night comes and then monsters just like launch at you and you're like defenseless. It's just pretty scary, actually. And when I was starting to play Minecraft, I watched YouTube videos. I also went to Wiki to look up what to do in my first day. And Wiki tell you that, okay, these are the tools that you must craft and you need to like prepare food. Otherwise you will starve. What kind of foods are good, right? It's all in the Wiki. And I also go to Reddit whenever I have a question. I treat that as a Stack Overflow. And Reddit people give a lot of good advice. And that's how I played Minecraft, even as a human. And that gets me thinking, right? Like, why shouldn't our AI use all of these internet skill knowledge? And if we want our AI algorithm to play this from scratch, it's almost impossible because exploration is intractable. If you just take random actions, kind of how big is the chance that you can stumble upon a diamond? It's almost literally zero, right? So that also inspired the algorithm approach that we did.
My experience is so different. It makes sense. I played some games that way, but some games are really fun to not look. There's so much like joy of finding the diamond when you didn't look anything up. It's like, wow, I like really solved this thing. I didn't do that in Minecraft, but there are other games where, I kind of like exploration, like sort of the game is almost has two sets of players. There's one set of players and most people that play, and like most of the time when I play games, play by like looking things up and learning. It's much more practical. There's another set that are more hardcore and like, I don't know, I'm only going to like do this just the way that's sort of like meant to be played in the purest way.
They're going to do pure RL.
Yeah. And I think it's a really good point to like, it's a lot harder that way. And it's a lot easier for our agents to do the thing that, we normally do in play.
Yeah. It's like
completely agree.
Discovering from first principles. In the foundation model you trained, can you go a little bit more into MineClip and kind of how the training process worked?
Yes. So to understand MineClip, we first need to understand the clip model made by OpenAI. So for that model, first of all, like clip model isn't embodied. It doesn't do policy learning. It's an image and text model. So the way clip was trained is you have a huge kind of internet scale database of paired image and text. And the text is typically a description of what is in the image. And then you learn an association between these two data modalities through a process called contrastive learning. And that means for the images and their correct corresponding text, you will pull their representations closer to each other. And if they're from like a different image or a different text that's not matched with each other, then you will learn to push their embedding vectors apart in the embedding space. And just by doing this over and over again, now you have like very good image representations and also text representations that kind of attract or repel each other, depending on whether their semantic contents align or not. So this is kind of a very general purpose idea, and it's not really limited to image and text. You can do it with any modality X and modality Y. So here in my clip, we repurpose this idea to make it into a reward function. So the way it works is now the modality X is a Minecraft play video, and the modality Y is still text. And here the text is the transcript that we scraped from YouTube, because as people are playing it, they love to narrate what they're doing. Oh, like today is a great day. It's time to hunt some pigs and get some diamonds. They'll just say it. And then you get all of these signals, right? Because the next few frames is going to be crafting weapons, meeting up with some pigs. And you can exploit this alignment to train using contrastive learning. And then once you have that, how to turn this into a reward model. So the way to do it is, let's say you have a task called harvest wool from a sheep. And given this text, the agent starts to explore. If the agent, let's say it navigates towards a sheep, then we can imagine that the correlation of the video that the agent generates will have a pretty high score with the text. And as you approach a sheep more and more, the score will just increase more and more. And if the agent is doing some random stuff or like approaching a wrong animal, then the score will be going to 0. So the score is between 0 and 1. 1 means perfect match. 0 means it's unrelated. And just by doing this, that sounds like a reward function to us. Like you can now shape the agent towards the behavior of harvesting wool from sheep, given this natural text. And by plugging it into any RL algorithm like PPO, you can train a pretty good agent for it. So that's how we do this process. I'm pretty surprised, like just by training on these videos can acquire all of these concepts just by itself. Like, and what are sheeps and also like what are some of the monsters in the nether world. It knows all about these. But on the other hand, I'm also not that surprised because I've watched those videos and those videos are very diverse. People talk about these concepts. It's a really good coverage. So yeah, at the same time, like, surprise, it kind of works before the deadline. Finally works before the deadline. And also, and also not that surprised that, yeah, it will eventually work if we give it diverse enough.
Do you feel like there's anything that you expected it to learn or become good at that it did not become good at?
Yeah, one of the main weaknesses of MineClip is the horizon of the task. So when we started out with this algorithm idea, we wanted the MineDojo agents to build a house. But then it turns out to be wishful thinking because the way we train MineClip is that each little clip is only like 8 to 16 seconds. And that is very much bottlenecked by the hardware. Because if you throw an hour of video, like just think about how much data that is, it won't even fit in GPU memory. It's like so hard. So we can only do like up to 8 to 16 seconds of video and then do this contrastive learning. And then this training process, by definition, will not be able to handle like much longer horizon tasks that takes hours of gameplay or even days. So there's no way we can build a house using this model because of the context lens. It's pretty obvious now in retrospect. Of course, if you cannot fit the training data in the context, then it will not be able to do long horizon. But back then, we really hope like building a house is kind of our major milestone to do. And that turns out to be much harder than we expected. But we also have many ideas to improve this, right? Like one obvious way is to increase the context length because video is very redundant. So we can actually do like smarter subsampling. So we can maybe capture hours of videos using not that many interesting keyframes. So that is like a pretty straightforward extension to it that we are exploring right now, kind of extending this horizon and also just scaling up on more data. And as I mentioned, people upload to YouTube every day and Minecraft is just going like this whole game is going stronger than ever. So we're not worried that we don't have enough data to scale up.
Are there any other kinds of potential approaches or solutions that you think are promising for this besides just, keyframe sample, I guess, there's some things like go to Mars, right? It's like, oh, that's a lot of work. You don't really want to have to take this whole thing and succeed at it and shove it into your like context length where you take one keyframe every year as you're developing a space shuttle. It's kind of hard.
That sounds like the right approach to me. That sounds very promising. Maybe MineClip holds the key to making us become interplanetary species.
Maybe in Minecraft we'll be interplanetary.
Yeah.
Yes, let's do that first. let's do that first. Yeah.
Yeah. So curious if there's anything else you feel like is promising or that you'd want other people to try.
I would highlight two works that I think are, very kind of interesting in terms of the algorithm approach. The first work is called Video Pre-training of VPT from OpenAI. And it's very interesting, VPT and MineDojo were developed completely independently by two institutes. We don't know each other are working on this. But somehow in 2022, people just converge on Minecraft. So that is a big surprise to me. And also I'm very excited to see a community kind of also rallying around Minecraft because of these works. So for VPT, OpenAI has a very, very different approach from ours. The way they do it is a few steps. First, you will hire a lot of humans to play Minecraft, and then you record their demonstration data, including all of their actions as well. And here, the key is actually going down to keyboard and mouse action space. So this is very interesting because I thought keyboard action only happens in the context of a world of bits. Never imagined it would happen in Minecraft. And when I read that paper, it feels to me that this is the right way to do it. And the reason is the second step. So once you have this human data, you can train an inverse dynamics model, which means given the previous frame and the next frame, you predict the action that enacted the change from previous to the next frame. And you can train an inverse dynamics model using this very clean human data. And once you have that model, you can use it to label in the wild YouTube videos that only come with pixels, but no actions, right? You can only see what they did on the screen, but you don't know the exact keyboard and mouse sequence that the YouTubers did to make this video. But you can use the inverse dynamics model to give pseudo labels for those actions. And here, the keyboard and mouse is crucial because you need alignment between the YouTube video action and the actual game actions. And keyboard and mouse is the bridge between them. You cannot use higher level abstract action spaces because otherwise the YouTube videos will be misaligned. And now using this inverse dynamics model, you label those videos, label many more videos than the human data. And now you have an augmented training set of demonstrations. And even though those videos have they don't have ground truth action labels, they're predicted labels, which can be wrong. And indeed, they have some error rates. But despite that, if you train a behavior cloning agent that just clones the actions given all the observations, you can do a pretty good job on long horizon tasks. So that is how VPT approach it. Very, very different from MineDojo. So I think the strength of VPT is now you can do kind of long horizon task by kind of imitating directly from the tutorial videos instead of indirectly learning from a reward function. But then there are also weaknesses coming with this method. First, cache. Cache is a big, well, I guess it's not a weakness for OpenAI, but it will be a weakness for most other researchers. So they spent $40,000. It's in their paper. They spent $40K on just collecting this human data set. And that is huge. That has a really big cost to do. And if you want to do this for other domains, you'll need $40K for every domain or even more. And second is this approach is not language conditioned. It's like learning from the videos, but they did not use the transcripts with the language. And I do think here language will play a very big role. One reason is language is used to do prompting. It is a very kind of natural way to interact with the model and specify the task. And as a result, in OpenAI's VPT paper, they could only do a limited set of tasks. And those tasks are still specified by hand-coded reward functions. And the second reason to use language is to do the grounding. And we do think it is very important in this kind of embodied agent setup to have the pixels, the video pixels grounded in language. So the agent, it not only knows what are these concepts, but also understands kind of the dynamics described by the language. So we do think language will play a key role from now on. And it's pretty important to have that in the model. Yeah. So I think VPT and MineDojo and MineClip are very much complementary and both are required to do a good job in Minecraft.
I think you might have said that there were two other ideas besides the scale it up and subsample.
Two approaches. One is VPT.
Yeah, one is VPT.
And the other one.
There might have been one other one, but I could have remembered incorrectly.
Yes. So the second one, I'm not sure if you guys know it, but there's this research company called Generally Intelligent. And they did a work called Avalon, a very cool work. I think you guys should check that out. Really great work.
I've never heard of them.
Please. Yeah. Check it out. Yeah, I think Avalon, and what Avalon brings to the table is this kind of very strong execution speed so that we can like really speed up this training framework. We can speed up this training pipeline. And also by like scaling up the training pipeline, we'll be able to collect a lot more data given the same kind of computational resources. And we know that if you scale up the data, many properties can emerge. Like we can rely on this kind of emergent property by crunching through like a lot more data and doing a lot more exploration given the same unit time. So just to also put things in perspective, Minecraft, it is very rich and complex. It's great, but it's very slow. It's about up to 100 FPS. And I think it's very understandable because the game is not optimized for AI. It is meant for humans. And once a team hits like 90 FPS, it's going to look good on any platform. And there's really no incentive to optimize it even further. And it's a game with like millions of lines of code, very, very complex. So like no one really knows how to optimize it beyond what we already have. So that becomes a bottleneck in exploration, in crunching through the data. But Avalon is like this custom built specifically for embodied AI research. And then the researchers can kind of optimize it, right? Just for AI. So it hits what, like 7,000 FPS something? Yeah. So that's about 70 times, like almost 2 orders of magnitude faster than Minecraft. And I do think like the speed matters here because at some point, the improvement in quantity will translate into improvement in quality. There might be a quantum leap as we kind of explore this emergent property. And the second thing that I'm very interested about the concepts in Avalon is this idea of a single reward function, which is like survival, a single objective. And it's a very different way to tackle the messy reward problem in world of bits. It's a very different angle. Instead of doing learned reward, instead of handcrafting reward, let's just have a single objective. But what changes is the environment. We change the environment, we change the task, but all you need to do is like survival. In this way, like this reward is universal. And of course, the action and observation space are unified across all the environments within Avalon. So this creates a really good research platform. And I think like it has very interesting ideas, orthogonal to both VPT and MineDojo, but it's a really kind of great platform also in embodied intelligence.
Oh,
Thank you.
Yeah.
I'm so glad.
Awesome.
MineDojo also has a single reward function, right? It just has mine and like that is it's language condition, but there's really only one reward function, I think, right? Or are there other reward functions as well that are handcrafted?
Yeah, so we can add handcrafted rewards to it. The mine clip itself is learned, but like the other reward functions like collecting diamond, there are obvious like shaping reward to it because to collect diamond, you will need to craft like wooden tools and stone tools, and you can give the agent reward as it goes. So it's kind of like a semi-sparse reward. Every time it's an integer, right? Like hitting this milestone, I give you 1 point. So it's not like a dense shaping reward, but still it's a handcrafted reward function. So we can still do that for many of the tasks. But for some of the creative tasks, which means like you don't have kind of a ground truth success criterion for these tasks, then you will have to use a learn reward function. And examples are, let's say, building houses, right? Building a castle. Like what makes a castle a castle? I think this is a very similar problem as image generation. Let's say we want to generate a picture of a cute cat, but what makes a cat a cat? Like, can you programmatically write a Python function that tells me these pixels are a cat? I don't think that is possible. You will need to use like a learned model to decide if image generation has succeeded or not. And in that literature, it's called the FID score based on the inception networks, learned neural network. And here we can have things like embodied FID score, which tells us, if you have succeeded at this task or not using a learned model. And for that, I think you will have to use approaches like MineClip.
Yeah, agreed. Yeah. If you do get a great generalist agent in Minecraft that is long horizon, where do you go from there?
I think a couple directions forward. So one thing is, I think solving the problem itself has a lot of value because Minecraft is played by 140 million people around the world. So if we can make a bot that can do tasks and more importantly, collaborate with humans, or even better, through a chat interface. Like I want to chat with a companion bot on my grand Minecraft adventure. And people do that all the time. Like a bunch of friends get together on Saturday night and just play Minecraft, right? That happens all the time. And that's why Minecraft actually supports chat as a native function of the game. Like you can type anything. There's a dedicated chat box. So that can be repurposed to talk to an AI. And that could be a completely different gaming experience just by itself. I'm not sure if people will pay for it, but that's a different question.
I mean,
Really
building on that actually sounds like a much more fun version of Minecraft. Do you know how boring it is to mine a diamond? It takes a lot of work. It takes hours of clicking. But if I could just say, hey, go give me some diamonds, you go over there and shoot your sheep, you go make a thing like this, like make a cool castle. That one's not that cool. Make it bigger. Like, just bounce around the agents, you know?
Yeah. I'm very excited if we can ever get there, and then we can maybe deploy this, right? Or like open source it. So that is one direction, more kind of like in domain within like the value it creates for the Minecraft community. I think the second direction would be more on the algorithm side. Like what have we learned from training this embodied GPT-3 in Avalon or in Minecraft? Or what have we learned from it? So to have that, we need to be careful not to overfit to these particular domains. Like in Minecraft, you can easily overfit, right? Like you can kind of query the broad truth state. You can just give it the recipe or doing some like hard coding, and you can solve some of the tasks, not all of them, but some of the tasks maybe perfectly. And there are already many Minecraft bots by scripting. Well, they don't solve it from pixels. They cannot do vision, but you can kind of cheat. And that completely defeats the purpose of MineDojo. What we want is to develop or maybe discover, right? Like general principles to embodied intelligence. That's what we want to do. That's what MineDojo and Avalon want to achieve, want to enable, right? Not just kind of solving these particular 1,000 tasks, the kind of the most brute force way. So yeah, just a word of caution to researchers, to resist the urge to overfit, to cheat, to use like things that are super specific to Minecraft that will not transfer elsewhere.
Yeah, a good point.
Yeah. You're also involved in BEMA, which is this kind of general robotics project. It's also linguistically prompted. How did you get interested in this paper, and what are your thoughts on it?
And maybe also just a quick summary for other people about like what it even is.
Yeah.
Yes. Okay. Yeah, sure. I'm very excited about BEMA and more generally foundation models for robotics. At the beginning, we briefly touched on this statement that the history of AI is a history of unification. Before AlexNet 2012, we have completely different paradigms for different tasks. And then after AlexNet, we started to use the same SGD algorithm, but to optimize for different architectures. Like AlexNet is a particular content architecture. Back then, if you want to do sequence modeling like NLP, you need RNNs. And for speech recognition, you need something else, right? Different architectures, but they share the same SGD, stochastic gradient descent. In 2017/2018, Transformer happened, and now we use the same architecture, but we train different models for each problem. And finally, 2020 marks the era of GPT-3. And now we actually reuse even the same model weights, not just the architecture, but the weights for as many tasks as possible. So if we look at the history of AI, it is unification. And the very sad fact is robotics is quite behind on this trend. Named 4 segments of this trend. I think robotics is still on segment 2, right? Like we use the same SGD, but completely different architectures for different problems, different setups, different pipelines, right? Like we cannot agree on a unified architecture, let alone part 4, have a single model for all of these. We're pretty far behind. So what VIMA wants to do is we want to take a baby step towards resolving this issue, towards pushing robotics forward. We want a generalist robot agent that has a very intuitive and expressive interface for many different kinds of tasks. And then to do this, we find that text alone is just not enough. So let me give an example of a household robot. So we can ask the robot, let's say, to bring us a cup of tea from kitchen. But if we want to be more specific, we can instead say, oh, bring me this image of the cup. This is my favorite cup. Bring me this particular image of the cup, not just any cup. And we can also provide a video demonstration of mopping the floor and ask the robot to imitate a similar motion. And let's say when the robot sees an unfamiliar object that's very particular to your house, we can explain by an image example of, oh, this is a new concept, and teach it a new concept on the fly. And finally, to ensure safety, we may just point to a room and ask the robot not to enter the room. Maybe it's a room for small kids. Don't enter the room when you're doing cleaning, right? We want to point to that room. And to enable all of these use cases I mentioned, what we need is multimodal prompting that can interleave text, image, and videos. And by doing multimodal prompting, we essentially unify all of the tasks that I just mentioned that are typically tackled by very different pipelines and algorithms into not just a single architecture, but a single model prompted by the same multimodal format to do all of these tasks using a model. And for the tasks I mentioned, if we put them in more kind of formal terms from the literature, it's like visual goal conditioning, which is, rearrangement and given a goal, achieve this goal, right? And for the video one, it's one-shot imitation. So you give the robot a quick demonstration and the robot learn from this demonstration one shot quickly on the fly. And also novel concept grounding. So we explain a new concept by an image, and can the robot quickly bind these pixels with this text in context and then use this concept when it's solving the robot task. And finally, visual constraint. When I say safety, it is like setting up the constraint. And constraint satisfaction is a big literature by itself in robotics, and visual constraint is part of this field. So can we kind of specify constraints in the prompt? So these are, pretty unique problems to robotics that are not necessarily in NLP or computer vision, but these are important ones if we really want to build a household robot that can be useful and safe someday. So Vima takes a step towards this.
I'm curious, how was Vima received by the field? And also, what are some of the interesting things that you're seeing now from it?
I think I wouldn't say surprise, but it's really a little pleasant surprise from the community is the main thesis of Vima is not controversial. I think that's what every roboticist or most people want, right? A journalist robot that can take in like any expressive task command and then just do the task. I think this general setup is what everyone wants, the users, researchers alike. So for that part, I'm very happy about it. Well, for the particular method, I think people can disagree. And of course, like Vima itself have some weaknesses, right? Like one thing is, and right now, as of that paper's writing, it's an imitation learning agent. Like it requires you to have like a data set of expert demonstrations. And we did not have 40K to spare on hiring human experts. So we generated from simulation. NVIDIA is really good at simulation and graphics. So we generated these data using a physics simulator. And by using a simulator, you can really scale this data set up as much as you want. And then we do imitation learning from there. But for more complex tasks, it could be very difficult to have a simulation that can reproduce all the nuances of the real physical world. So yeah, I think the approach, Vima is like one of the first models on this. It's more like exploratory work. It will not be able to just like solve robotics tomorrow, but we get the conversation going, right? Like this interface, like we agree on the interface, and then we can scale up the model, we can tune it, we can talk about data, or maybe can we add some reinforcement learning in the mix? Can the robot do exploration by itself? We can always add these components back. First, we need to be on the same page about the interface. And I think for the NLP community, people have agreed on it for a long time already. We're so far behind. 3 years ago, people know that text in, text out is great. Well, it's pretty silly to say it now, but back then it wasn't obvious. And then after GPT-3, after transformers, after like T5, people agreed like text in, text out, kind of the most universal expressive interface. And we can do different architectures, we can do different models, but interface is there. That is the right one to do. I think for robotics, we also want to see this moment.
That's interesting. That's a really good way to put it. Do you think the multimodal prompting is at all interesting for other environments like Minecraft?
Yes, I think it is generally applicable to many domains. Like in Minecraft, you can give an image of this is the castle I want to build. Now, please maybe build some variations of it, right? And this is an example of visual goal conditioning. And also we can ask a human to demonstrate a new skill in Minecraft on the fly. And honestly, like new skills coming every day on YouTube. People always discover new things to do that are not in the training set, right? Then can I just grab a YouTube video, upload it maybe 10 minutes ago, and then give it to the agent? And the agent, without retraining, without fine tuning, just in context, look at this video and say, okay, I know how to do this skill now. And now I'm going to do it on my first try. So that is one-shot video imitation learning in the context of Minecraft. And similarly, like safety constraints and all of that. Well, in Minecraft, maybe we don't care about safety that much. But of course, you can also say, oh, this is my territory. Don't come to like my territory or something like that, right? That could also.
Assemble my building in order to build your...
Exactly. Yeah, maybe that is some adversarial AI that you want to prevent.
I'm super curious, like what work of yours do you feel like was most overlooked? Maybe you thought it was interesting, but others didn't seem to get it.
Yes. So there's this one work last year that I collaborated with Stanford co-authors. The paper is called Metamorph. So it was accepted to ICLR. And this work is about how can we learn a policy that controls not just one robot, not just 10 robots, but 1,000 robots. And each robot can be different in their morphology. Some may have 3 limbs, others like 4 arms or things like that. Like they can have different joints and connectivities. And because they have different morphology, they will have very different kind of physical properties and dynamics. And can we learn a single policy to control all of them? So that is what Metamorph was about. And technically, it also uses like transformers and many of the pre-training ideas that we talk about. And it has really good performances in unseen morphologies. So I think this is a work that is worth checking out for the audience.
Why do you think robotics is stuck back in the like sort of phase 2 of like how do we get people even on the same page about the right interface or what we're trying to do?
I've been thinking about that myself a lot. And I wouldn't blame like any researchers in this field because I feel that this like robotics is just a much harder problem. And we are very much in the thick of the Moravec paradox. So that paradox states that things that we think are difficult for humans are actually not that difficult for AI, and vice versa. Things that are simple for AI may be very difficult for us. So that is the Moravec's paradox. And the robotics robotics versus, let's say, ChatGPT is very much like that. We think it's very difficult to write poems ourselves, write creative like plays for theater. But ChatGPT seems to be no problem at it. It does a pretty good job. But it's so easy even for a 5-year-old to do very complex hand manipulation, like stacking Legos, manipulating toys, all of that. It's very easy for human children to do it, but so hard for the AI. And I think the reason is, first, the hardware. The hardware is really not there yet. So we have seen very impressive hardware from Boston Dynamics, right? Doing like backflip and all of that. But first, they don't have hand dexterity. So it's very good as like a whole body kind of robot, humanoid that can do all of these gimmicks. But using like the 5 fingers, it requires a lot of like very precise motions and finesse. It's difficult for the hardware. So there are some companies doing like 5-finger hands, let's say the shadow hand, but it's very brittle. And more importantly, it's super, super expensive. It's slow, brittle, and expensive. So that makes the barrier to entry for robotics very hard. And second is data. I think robotics has a much more serious data issues than any other fields. And for ChatGPT or Stable Diffusion or DALL-E, all of these revolutions, they're powered by data, right? Like we have so much text on the internet, more than we can process, and it's growing every single day. And we have so much like image and text pairs, like 5 billion of them in the Lion data set. And again, it's growing every day. So those make the text and text to image foundation models possible. But scaling up data is much harder for robotics. For one thing, people can't agree on the same hardware across different labs. And it's no one's fault because the hardware is expensive and different labs have different budgets. Some labs can buy like 20 robot arms and others can only buy some very simple models. And yeah, that creates a big gap in terms of data. And you can't just like collect using one arm and expect it to transfer magically to another robot with completely different morphology. And by the way, that's also one of the motivations of Metamorph. Can we train a single policy across all the morphologies? That's another thing. But before Metamorph, and like even today, it's still really hard to transfer across like these very sophisticated but different robot morphologies. And the other thing is we have a lot of internet videos, but it's really hard to leverage those videos for robotics because it's mostly like humans doing things. And humans, again, have a very different action space from robots. So it's very hard to transfer directly from, let's say, a cooking video by a human chef to a robot arm to cook this particular meal for me. There is a big, what we call embodiment gap. And this gap is so hard to overcome. And because of all of these, robotics is falling far behind. It's very difficult to scale up. And that's why we have not yet seen like a ChatGPT moment for robotics.
That makes sense. Yeah. Do you feel like you have any strong intuitions or theories about important directions that you want to investigate?
Yeah, I think one thing is data. As I mentioned, this is the most important thing. So how can we kind of scale up the data collection, cleaning, and also overcome the embodiment gap? So the good thing about MineDojo is there is very little embodiment gap because the pixels that you see on YouTube is very similar to the pixels in the game. And even with no embodiment gap, we still cannot learn like a super strong policy yet. We cannot build houses or castles yet using any of the state-of-the-art algorithms, even for that. But still, like it's a simpler problem. But in robotics, kind of how can we overcome the embodiment gap? So one idea is to apply things like Minecraft, right? Like instead of extracting the actions, which means you need to overcome this gap, why not just extract a reward function? Can we kind of reward the robot when it's doing this dish correctly? So let's say if, cooking meatball spaghetti requires 20 milestones. So hitting each milestone gives the robot some reward. And this reward function can be learned from internet videos, even though it's like some humans doing this particular cooking task, right? So that is like one way that we can transfer insight from MineDojo to robotics. So that is another direction. And the second thing for robotics in particular is, can we kind of make hardware cheaper and also more versatile? But again, like this is a bit beyond my expertise. It involves mechanical engineering and all of that. It's a super, super hard problem. So I'm glad like many researchers are working on this, and please work harder. I want to test the algorithms on a really cool robot hardware platform, but we don't yet have that.
Yeah.
We don't yet have like affordable, dexterous platforms. Yeah.
You mentioned scaling up data is the most important thing. Are you interested in exploring things like, planning, reasoning, curiosity, these other types of things that it seems like agents don't necessarily exhibit that much of today? Or is that something you think will happen automatically? Other people can do it.
So I think you said like planning and exploration. I think these are like the key puzzles that we need to solve before we have this embodied GPT-3. And I mean, of course, like if the agent cannot do exploration good enough, it will not survive or do anything interesting in open-ended embodied environments. And planning is crucial if we want to do long horizon tasks. So let's say beat the Ender Dragon. And this is like one of the kind of the main achievements in Minecraft's gameplay. And this single task will require probably at least 1 million action steps by my back of envelope calculation, at least 1 million. And that's in contrast to like Atari games and other like popular RO benchmarks that are typically 1,000 time steps max. But we're talking about 3 or even 4 orders of magnitude more horizon. And to do this, you can't just memorize the whole thing, right? Like you will need to do hierarchical planning, break it down just like a human, collect the resources, do all the necessary crafting and tool building. And by hitting all of these small milestones, we can assemble them together into finishing this grand mission of beating the Ender Dragon. So planning is absolutely crucial here. So I think, these are all important questions. But do we need completely new algorithms for planning or exploration? I think that is a totally different set of questions. I would say planning and exploration are required, but maybe we don't need like completely new or innovative things to solve this. There's one quote I really like from Ilya, chief scientist of OpenAI. So he said, what we want to do is maximal impact with a minimal innovation. So innovation for its own sake is not interesting. Impact is interesting. And sometimes we don't need a lot of innovation. And just by carefully tuning and scaling and addressing like the little weaknesses of existing methods, it can go a long way. There are way too many examples to name. Like GPT is just one of the best examples out there. But in the realm of policy learning, I think PPO is another great example. Right? Like PPO, which stands for Proximal Policy Optimization, is one of the most effective RO algorithms out there. And it's like 7 years old by now. And there are thousands or maybe tens of thousands of papers built upon PPO claiming to improve it by adding fancy stuff to it. But none of them is as scalable and high performant as PPO. And in fact, PPO is used to fine tune ChatGPT, which is what we get today. All of these great performances is just done by PPO. So do we really need like completely new things for planning and exploration? I'm not sure about that. But I'm happy to be proven wrong. But I feel that by leveraging the old ideas to train them scalably and to build like good infras around it, like great simulators like Avalon, like these are infras efforts that make scaling up possible. And by doing all of these things, maybe planning and exploration will emerge.
Yeah, totally. I agree. What do you feel like are some of the most important open questions to you at the moment?
Yeah, I think how can we resolve this Moravic's paradox? Now we have extremely strong language modeling that can do sophisticated reasoning like ChatGPT, but we can't do things that 5-year-old can do. How can we bridge this gap? So at the beginning, I mentioned that human babies are fantastic learning machines. They are extremely sample efficient. And they don't have more knowledge, but they can learn to acquire concepts faster and faster. So how can we bridge this paradox? How can we kind of use inspirations from like developmental psychology or other literature to really help bridge this gap. And also like scaling up algorithms, making hardware better to kind of bridge this gap.
From your perspective, like what kind of multimodal foundation models seem interesting, or what kind of capabilities you'd want to see that you feel like we don't really have?
Yeah, so I really want to have access to the weights of ChatGPT. That is like, I guess like many researchers are thinking the same thing. Because like ChatGPT is we can think of it as a big reasoning machine, right? Like it kind of reason it's a single modality, but the text modality contains a lot of important characteristics that we need for embodied agents. Things like planning. ChatGPT can do planning, right? In text domain, it can explain plans to you. It has like hierarchical thinking. It's compositional. All of these are required in embodied agents. So instead of like reinventing the whole stack, can we kind of hook different modalities into this reasoning engine, the reasoning backbone provided by ChatGPT, and then like give it vision, give it like touch sensors, give it arms and legs, and then recast it into this embodied agent setting? That would be like pretty amazing to have. Yeah. So I think the sad fact is like most of the open source language models, they're just not good. If you have played with it, zero-shot prompting, you know that it's like nowhere close to GPT-3 or ChatGPT's performance for in the wild prompts, even though like they look really good on paper. So don't get me wrong, like I have a lot of admiration for the researchers who open source their models. But just that like, OpenAI has this, scaling and reinforcement learning from human feedback pipeline that's really hard to reproduce elsewhere with much smaller budgets. That would be my answer. Like, can we kind of use these reasoning backbones, these large language models as reasoning engines, and then add embodiment on top of that? And that could be a very interesting direction to pursue.
Interesting.
What are some recent papers or ideas that you've seen that you're actually really excited about? Maybe that we haven't touched on so far.
I think on the reinforcement learning from human feedback, which is kind of the paper behind ChatGPT, the main technique behind ChatGPT, I think it's very exciting, not just because it delivered ChatGPT, but also because it's like a general purpose paradigm to align powerful AI systems with human intent. And I think it becomes super relevant these days. Maybe a couple of years ago, it's not that relevant because AI systems just fail at the most basic things. The moment you go a little bit out of distribution, it fails. We don't even have anything to talk about human alignment. But now it becomes super relevant because we have these powerful reasoning machines that can answer questions, that can like give you plans and advice. And if they are not aligned with human intent, user experience will be bad. And more dangerously, like it could give you misleading information and even harmful information, right? So like how to kind of align that with human intent. And I think this reinforcement learning from human feedback idea applies to many other domains as well, like the image to text, for example, or like embodied agents at some point. But I suppose embodied agents are just not that good yet. Like we don't have an agent that can be given arbitrary natural language and can build anything you want in Minecraft. But let's say if next year or 3 years from now we have that, then we can align it with human intent much better using this kind of approach. But we need to have a pretty good base model to start with. And then the second implication of ROHF is that prompt engineering will go away eventually. Like it is something fleeting. And the prompt engineers is just not a real job. Let's face it. The reason prompt engineering will not be relevant forever is because of ROHF. Why prompt engineering even exists in the first place is because these systems are misaligned with what humans want. So we have to kind of coerce the model to give us what we want by typing out very unnatural sentences and to essentially trick the model into solving the task. But what if we can just tell it what task we want to solve in the most natural language that we can come up with? Then this whole prompt engineering business is no longer needed. Even my grandma can use ChatGPT and solve her task on the first try instead of having a learning curve of how to interact with ChatGPT in the most effective way, right? I believe this is a bug, not a feature. Prompt engineering. It is something that is an artifact from this misalignment between model and human. And as this gap is shrinking, so is the prospect of this career.
One question that I have about RLHF actually is, do you see any kind of dangers to doing this kind of alignment thing, like, human feedback. Well, maybe what you want for a sandwich is different than what I want for a sandwich, right? Like maybe there's actually not just like one human goodness, but there's actually like a lot of diversity. I think, especially when you start playing around with like Mechanical Turk, workers labeling things, and there's like incentives to label them more quickly.
Right.
There's other sorts of like, we've seen reward hacking things, or sort of like, it's kind of giving you what you want or what you say you want, but that's not really what you want. How do you think about those sort of things and how they relate to RLHF?
I think that is a very hard problem to solve. And it would, like the quality of RLHF, as you mentioned, it will come from the quality of the input data, also of the feedback, the quality of the feedback that the human annotators give ChatGPT. So for that, I don't really have a good answer on how to address this. And I feel like it's probably OpenAI is investigating this heavily. Maybe like they will come up with a way to kind of incentivize its data annotators to be like more diverse, and also like to game the system less and less as they observe these kind of reward hacking behaviors, if any. So that's one thing. But from an end user point of view, I feel that one of the kind of the biggest strengths of a dialogue system, not just a generation system, but an interactive dialogue system, is that the AI now has the chance to ask you follow-up questions, to ask you to clarify what exactly do you want. I think Josh's example is great. Like, I want a sandwich. Then the AI should follow up, like, what kind of sandwich do you want? What sauces, right? Like, are you vegetarian? It should be able to ask these questions to guide the human and to give it better and more specific intent, because we can't expect everyone to give like the full specificity in one go. And it's not the way we work as well, right? We talk to other people. We also ask for clarifications and follow-up questions to minimize any misunderstanding. And I think like that part I'm most excited about, like having this dialogue system itself, this format itself, help align the intent better.
One last thing on that, like it's a good example of like, asking questions like, what sauces, et cetera. But perhaps very particular about my sandwich. Other people are just, I just want this. So there's actually a preference over how many questions. There's like all these levels of preference of like different people might want very different things. I think that's, and actually in the real world, people definitely do want different things. I think maybe one of the things that I feel a little bit worried about or skeptical when I look at, we're going to, GPT with RLHF, we're going to make it what humans want. Well, who are those humans? And you're making just one system. It's not like a per user system. And so I feel worried about the reinforcement learning kind of drifting in maybe the average direction or in the kind of direction that we didn't necessarily want as a society.
I think that touches on the important topic of personalization for these foundation models. I have not seen very effective personalization for ChatGPT or like large language models, but we are seeing a wave of papers on how to personalize Stable Diffusion and DALL-E, these kind of image to text generative models. And in that context, the personalization is super important. I may not necessarily want a cute picture of a cat at a party. I want a cute picture of my cat at my party, right? I want to customize these concepts, and how can we do it? So we're seeing like research on concepts like text inversion, where you invert like the specific, let's say your cats, the pictures of your cats into a token, and then you can use that token in any subsequent generations from Stable Diffusion. So, and the model will only output pictures of your cat in like all kinds of fantasy scenarios. I think the text to image community is doing this a lot better than large language models or like embodied agents.
I think maybe one reason for that is that it's much easier for lots of people to play around with this and retrain this. I think if it were just as easy to retrain GPT-3, maybe we wouldn't see these types of variations and personalizations.
Yeah.
Right. And also there are some efforts on like minimizing the retraining and fine tuning. So some of the earlier works require kind of propagating the gradient through all of the layers, but there are also like clever ways to make this much more efficient. So I feel that in 2023, just this year, we'll see like plug and play solutions that you can give it new concepts in context. Well, very much like Vima. Vima wants a robot agent to bind new concepts on the fly, and we show that it's possible with enough data, of course. And I think that the same thing will happen for Stable Diffusion and also maybe likely for ChatGPT or GPT-4.
Yeah, that certainly seems like it's going to happen. What are other things that you feel like are going to come out this year or maybe next year that you feel excited about?
I'm glad you asked this question. So I have quite a few things that I hope to see in this community. So it's also a call to action. Everyone, please work harder. To make these happen.
I love it.
Yeah. So the first is text to video. So we have seen some works last year about like generating high resolution videos using like arbitrary text, essentially extension of Stable Diffusion, but in video domain. But those works, the videos are pretty short. They're still blurry and nowhere close to the quality from DALL-E or Stable Diffusion. So this year, can we see video generative models that are actually good, that can actually be put in production and pass the visual Turing test? Essentially, you cannot tell if an artist or an AI created this particular video from the text. I feel that for Stable Diffusion and Midjourney and many other models, they have already passed this kind of artistic Turing test, but definitely not the video models. And I think like these will be a big game changer because like Hollywood is like a multi-billion industry and also like games as well. And for these, if we can kind of generate videos given text and if they're like as good as what humans can create, then there will be like a much more value created in those industries. So that's one thing. And a related thing is text to 3D. Like, can we generate like full 3D scenes from text? Again, we have seen some early works in 2022, but they're not good. They show some promising future, but they are like nowhere passing the 3D Turing test. So these two like are more on the generative model side. And the other direction that I hope to see is kind of still in the language domain, but can we push like reasoning and domain specialist knowledge to the extreme? To put it in like concrete benchmarking terms, I want to see an AI that can score, let's say 130 on an IQ test, or top 5% on SAT, or not just pass the bar exam, but top 5% in a bar exam to be like a qualified lawyer, a doctor, CPA, etc. Right? Like I want to see AIs kind of becoming superhuman in all of these like domains that require very specialist knowledge. So ChatGPT is more like an average person, I would say. Well, it's pretty good at particular things, but for very domain specific benchmarking, it's like an average student at best. And also it hallucinates a lot. It's a stochastic parrot in many of these like medical and law domain. And that makes ChatGPT very unreliable. And for anyone listening to this, do not take medical advice or legal advice on ChatGPT. They're not that good. But maybe this year or next, we will be able to take legal and medical advice from ChatGPT if it's able to kind of pass those exams and justify their output based on evidence, not just hallucinating, but actually telling you, oh, this is a particular medical paper that I cited for this particular treatment. And if you want to verify this medical advice from ChatGPT, you can. Just like when you go to a human doctor, you can ask, okay, why are you making this treatment? And they can justify it to you, right? I think that is very important for like domain specialists. And I feel we may be able to see this either this year or within the next couple of years.
What do you think makes a great researcher great?
Great question. So for me, the singular most important thing is research taste. I think it's much more important than implementation, coding skills, how fast you write papers, etc. Like how well you tune hyperparameters, right, etc., etc. I think research taste is the hardest thing to develop and also like one of the most important to really guide your research career. So I wouldn't say I have good research taste in my early career. I jumped a lot around like different topics, mostly kind of like just trying out different things and chasing what is the hardest right. Oh, speech recognition is pretty cool. Let's do speech recognition. I can get a quick paper out of it. There are a lot of like low-hanging fruits in semi-supervised learning. Let's do semi-supervised learning. Low-hanging fruits. I can get like 2 NeurIPS papers this year. I think that is the wrong mindset to have for like PhDs or research labs. But developing research taste takes like a lot of time and trial and error. I don't have a formula for it, but I'm more like, I would say, a trained discriminator on this. So I can tell if a taste or a particular research direction is good or not. But it's really hard to justify why I think it's good. It's more just from the experience. But now like I have like this model to say, okay, this is a research worth doing. This is not something that I want to spend my precious time on. And this discriminator model is data driven. So the data from all the years of sweat and tears during PhD, and you have this model. But I do think it is a crucial component.
In terms of advice for the PhD students who are listening, is it like collect and learn from as much data as possible, or what would you them to do?
I have a very specific advice for them. It's like an algorithmic advice almost. So there's this scale here where on the, let's say on the left-hand side of the spectrum, it is like incremental work. but it can get you papers. It can also get your hands dirty in this particular field. You get to do things quickly. And on the other side of the spectrum, it's like a very kind of moonshot projects that could be very high impact, but also very risky. And a lot of thinking goes into it. And you may not have a paper for like an entire year or even more than that. Mm-hmm. So there's this whole scale. And I would say during a PhD time, do like a linear or exponential annealing towards that. So at the beginning, do some incremental work. I'm not saying like all the incremental works are bad, right? Like incremental work or low-hanging fruit is a great way to get into a field, actually do the coding and get some like quick rewards to get yourself motivated. And more importantly, also get some papers on your record. So you prove to the world and maybe prove to your internship recruiter that you are able to do the implementation and do good research. At the beginning, you should definitely do that. But towards like the end of a PhD or later in your research career, do an annealing, right? Like anneal towards more moonshot. Now that you have a good track record, now that you know the nitty-gritty details in this field, it's time to stop writing LaTeX, publishing papers like crazy. It's time to just sit down and think through like, what does the entire field really need? What is kind of the big trends and the most promising, not just the hottest trend, but the most promising trend that will stay relevant for not just like the next conference deadline, but will stay relevant for the next 5 years. And you anneal towards that. And how do you kind of tune this schedule? It is a hyperparameter tuning exercise that will leave for the audience.
I love it. And on that, we're going to end here. Thank you so much for taking the time, Jim. This is super fun. And I love a lot of your ideas. Of course, they're very aligned with, what we're interested in working on. So we really appreciate having you.
Yeah. Thanks, Kanjun and Josh. I think this is amazing.
Thanks for listening to the Generally Intelligent podcast. If you like this, please consider giving us a rating and leaving a review on Apple Podcast. On Twitter, I'm @Kanjun, Kanjun, and our lab is @GenIntelligent. Until next time.